We're going to work on, again, reactions involving hydrocarbons, but we're going to add different chemicals to them. Some of the chemicals that we're going to add right now are halogens in their diatomic form. Halogens. So remember, what are some of the halogens that are most commonly used? We're going to talk about chlorine in its diatomic form, iodine in its diatomic form, fluorine in its diatomic form, and bromine as well. Or they're acids as well. Hydrochloric acid, hydroiodic acid, hydrofluoric acid, and hydrobromic acid. So let's see what happens to this. Let's begin with a simple molecule such as ethene. It's only 2 carbons that are double bonding. And the first thing we're going to do is we're going to add chlorine. So when we add chlorine to this molecule, what we're effectively going to do is we're going to break this double bond, and on each side of the molecule, we're going to take 1 chlorine and put it on this side, and 1 chlorine and put it on the other side after we broke the double bond, and this is my answer. I get a halogenated alkane or an alkyl halide with chlorine on both sides. What happens when we take the same ethene molecule and we add an acid to it? In this case, we're going to add hydrofluoric acid. So again, action occurs at the double bond, and what's going to happen, we're going to break it, and on one side we add hydrogen, which I'm going to represent. You don't need to do this, it's just so that you understand where it's going. This hydrogen, I'm just going to draw a dot to imply that it's there, and here on this side, I'm going to draw fluorine. So this molecule integrated into the alkene, we broke the double bond, and we have this together. If you get more complex molecules, don't worry about it, because the same thing happens. Let's draw this really long molecule with the double bond in the middle, and if I add iodine, for example, the atoms are always going to go on the carbons which are involved in the double bond. So that means iodine will not be on these atoms. It will be exactly at these carbons. So let's count just so that we don't make a mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I draw my molecule again with 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know that the iodine is going to go on carbon 5 and carbon 6, which is where I originally had my double bond. So I count 1, 2, 3, 4, 5. One of the iodine atoms here, and at 6 we draw the other iodine. So don't be intimidated by the length of the molecule. Just look for the double bond, which is where the action is going to occur. Remember, in reactions, the specific reaction will always occur around the functional group.